Today, we're going to talk about Nodestream, a Pythonic open source framework for graph-based ETL operations. Nodestream is available on GitHub if you're interested in following along today. So what we're going to do is we're going to take some data, run it through Nodestream, and turn it into a graph. And then we'll inspect our results with g.v and see what kind of visualizations we can make from our new graph data. If you're familiar with graphs, then you're probably also familiar with the common applications, things like cybersecurity, fraud detection, and social networking. Today, we're going to look at an application that takes a more literal approach to the geometric layout of a graph, which is public transport links. So what we're going to do is we're going to devise a graph where the nodes represent stations, and then the edges are going to represent transport links. So for example, train lines or bus lines, or because we work in Scotland and we have islands, we're going to include ferry lines as well. One of the nice things about using public transport data is that it's usually publicly available. So because we at g.v are based in Scotland, we took ours from the official ScotRail website. You can find the data we used on our GitHub, or if there's another region that's particularly interesting to you, you can probably find it online. If you decide to use our data, you'll find that we put all our stations or nodes into one singular CSV file, and then we put our edges or routes into a series of CSV files which we labeled by either the train line or we put all the bus routes and the ferry routes together. So inside each edge CSV, we can see that we have station nodes linking up to station nodes. And you should note as well that you could add extra information into the columns, and Nodestream is able to turn those into properties of nodes or edges during the graph creation process. Okay, now that you've got your relational data set up, let's talk about how to configure Nodestream itself. So Nodestream is a YAML-based framework, and within Nodestream, everything tends to revolve around one YAML file, which is called nodestream.yaml. This file will define all your sub-pipelines. So these are all the little steps that go into your pipeline, turning your data into graph data. This key file, nodestream.yaml, also defines how you connect to your graph database, which could be a Neo4j instance or an Amazon Neptune graph. Next step is to actually code your files. So that includes both your central nodestream.yaml file and then all the subpipelines that go into that. So because it is a YAML-based format, that means that it's super readable code, and that means it's really easy to pick up and very intuitive. You will get the hang of it in no time. Once you've written your code, you're basically done. Just run Nodestream and watch your data turn into a graph. The final step is just to connect up to g.v and see what the result looks like. Connecting to g.v is really easy. All you need is your authentication details, and you'll be ready to visualize your graph within seconds. As you can see, I had a lot of fun using g.v's customizable interface to get creative making some transport map designs. Well, there we have it. That was Nodestream, a framework for extracting, transforming, and loading your data into a graph-based format. My favorite aspects of Nodestream is just how easy and intuitive it is to pick up. I think the YAML format works great for new users and meant I was setting up my pipelines within minutes or even seconds. I would definitely recommend Nodestream. I think you should check it out. And that's all from us at g.v for this tech feature. Catch you next time.